Hello everyone and welcome to a new video in our programming series using MATLAB. So in today's video we will discuss the so-called logical operators. So we would like to discuss logical operators. There are three key logical operators that are used in programming. There is the AND operator, there is the OR operator, and there is the NOT operator. Let's learn the syntax of MATLAB for each one of them. So in MATLAB, the AND operator is given by this, or maybe double AND. The OR operator is like this, or also possibly this, and we will explain the difference when to use this one and when to use this one. The NOT operator is only given by the tilde sign. So let's get started with the AND operator. But maybe before going into the details of the AND operator, you should clarify that these operators, they operate on two logical data type or two operands which, and the final result will be a logical result rather than a number. So let's actually start by clarifying the AND operator. Let's get a new page. So AND operator. The idea is as follows. So if you have a statement that's true and you apply the AND operator to another statement between two statements, both of them are true, then the final result will be also true. If one of the statements is false, whether the first or the second, it doesn't really matter, and you apply the AND operator between them, the final result will be false. And finally, if both the statements are false, then and you apply AND operator to them, the final result will be also false. Let's test something along these lines. Just let's say, for example, 5 greater than 3. So this statement is true. And remember, we said that the AND operator is either represented by a single ampersand or double ampersand, and we will clarify the difference in a second. So AND, 6 greater than 0. So both these statements are true, and as such, the final result will be also true. So if I hit enter, the final result here is true. All right. So let's also try another one. So 3 is 3 equal to 4. So obviously this is false. And is 7 greater than 4. So the first one is false. The second one is true. So the final result will be false. Did we make a mistake here? So maybe we need to leave a space in this one. Yes. Yeah, so the final result here, so because one is false and the other one is true, the final result is false. Let's take one other example. Let's say both statements are false. So for example, is 5 equal to 8? And another statement is, 0 greater than or equal 9. So both of them are false, so the final answer is false. So this is basically the AND operator. It applies to two statements, and it allows you, the final result will be a logical data type as you saw here. All right, so maybe it's about time to clarify the difference between the double ampersand and the ampersand, the single ampersand. So let's do this in a new page. So the double ampersand works only for scalars, and it uses what is known as short circuit. While on the other hand, the single ampersand works with both scalars and arrays, and it doesn't use this short circuit thing. So if you notice, everything here was a scalar because the final result of this statement is just a single data type, which happens to be false. right? I could also use a single ampersand. So in fact, let me go up and do a single ampersand here. Yes, it also works, no problem. What is the idea of the short circuit thing? What do we mean by short circuit? Short circuit is an efficient way to determine whether the statement is true or false. So let's actually clarify this maybe by an example. So suppose I have a true statement and another true statement. So the first one is true. Because the first one is true, I have to wait. So the computer has to wait. There is no short circuit here because depending on the other statement, if the other statement is also true and there is an AND operator between them, then the final answer will be true. But if the other statement was false, it will give me false. So there is no short circuit here. However, if the first statement is false, then I don't need to wait until, or the computer, in other words, doesn't need to wait to see what is the second statement, whether it's true or false, because it doesn't matter. In both cases, the final answer will be false. Because of this, the short circuit thing is faster, is more efficient. So, for example, in the case here, since this is false, automatically the computer doesn't need to evaluate the second. Of course, if I use the double ampersand, or there is a short circuit, like in this case. But with a single ampersand, it's not a short circuit, which means that the computer needs to waste time and calculate the final result of the second statement, even though since the first statement is false and this is an AND operator, the result is guaranteed to be false. Okay, so it is really recommended to use the short circuit AND with the scalars. The problem only happens with arrays. And so in fact, let's take an array here. So let me clear this. Suppose I have an array of logicals. Let's say 1, 1, 0. Remember, 1 is true, 0 is false, right? And I'm trying to compare this with, maybe false, true, true, right? False, true, true. So obviously the result is going to be false. The second element of the array will be true, and the third element will be false. So let's actually check this. So yes, false, true, false. Now here I have to use a single ampersand. If I use a double ampersand, MATLAB will complain that there is no short circuit here. So if I do this, if I put a double ampersand here, MATLAB will automatically complain because it works only with the scalars, right? So in summary, the double ampersand only works with the scalars, and it's really preferable in the case of scalars because it applies the so-called short circuit thing. While a single ampersand only works with both scalars and arrays, but it does not apply the short circuit. Now let's move to the second logical operator, which is the OR operator. All right. So the OR operator, we can make a quick truth table here. So let's get a yellow color here. So suppose the first statement is true and the second statement is true, and I'm applying the OR operator here. So the result will be true, the final. So suppose the first is false and the second is true, so also true. First is true and second is false, the final result will be true. So you see, if only one of them is true, then it's guaranteed that the final is true. And because of this, you can come up with a short circuit, right? Once you see a true, the short circuit solution is that automatic, and this is an OR statement, so it's also true. In this case, I cannot do a short circuit because the first statement is false. So it really depends on the second statement, which happens to be true. And finally, if there is a false and false, then the final result is false. So this is sort of the truth table for the OR operator. So let's do, let's do an example here. So you see, 5, if I take 5 is greater than 3, so this is true. Or, right, or, let me make a false statement here. Maybe -1 is greater than 3. So I have true and false. So the final answer should be true. As you see here, the final answer is true. All right. Maybe let's take two statements that are false. So negative 6 equals 9, and maybe, actually let's do something that sort of review. So okay, negative 6 equal 9, or sine pi. Remember this from the previous video, or sine pi equals 0. As you see here, this is actually false, and this is also false, so the final result should be false. All right, so this is basically the idea of the OR statement. Now, what is the difference between double and single? So it's exactly the same as in the case for the AND statement. So the double it only works with the scalars, and it uses a short circuit. You see, it uses a short. So sometimes I don't need to evaluate the second statement because it's guaranteed that the final answer is true. For example, it's true. Okay, so like in this case here, since this is true, regardless of the second statement, the full result for this logical operator will be true. So there is no need to waste time on the computer to evaluate the second statement. While the single OR here that you see here works with both scalars, and also it works with arrays. Problem is it does not use a short circuit, right? So if you have an array, so let's actually take an array example. So let's clear this. Suppose I have an array of logical. So let's say true, false, false, and I'm saying this, or an array of 3 elements. So let's say, true, true, maybe false. So the first one, the final result will be true, true, and false. So true, true, false. All right. So with an array, I have to use the single OR. If you try to use the double OR, it will tell you I cannot use a short circuit OR because it only works with scalars. All right. While with the scalars, so let's actually take an example with the scalars. So if I have a true or another true, maybe, yeah. So this is fine. That works. It gives you true. Or you could use the short circuit, which is preferred here in this case, and it will also give you true. All right. So that's the OR and the AND statements. Now, the last logical operator that we would like to clarify here is the NOT operator. And that's very easy. And it's simple in MATLAB is tell them. Basically, NOT flips. It flips. What does that mean? If there is a true statement, it makes it false. And if there is a false statement, it will make it true. So let's actually take a couple of examples on this to clarify this idea here. Okay. Suppose I'm asking MATLAB to do, so let's clear here, not 5 greater than 3. So 5 greater than 3 is true. And with the not, the final result will be false, right? Suppose I ask MATLAB not, 1 equal 2. So obviously the 1 in parentheses is false. And then with the not operator, it will give me true. Sorry, I didn't put the not operator here. Oh yeah, we didn't put the not operator here. Okay, that gives me true. There's a main comment here that if I type not, let's actually clear here, if I type not 0, so remember 0 is false, so not 0 is going to give me true, right? And one last thing, any non-zero number is considered true by MATLAB. Notice that this is a MATLAB thing. It's not a common programming thing. The truth table we made for and or and not is really a common programming thing, and even in electronic circuits, it's a very common theme. But the specific detail here that MATLAB considers any non-zero number to be true is something really related to MATLAB. So for example, I can type, not 3. So 3 is true, not 3 is going to be false. Okay, I can try not negative 4. Again, negative 4 is true, and not negative 4 is false. Okay, so let's recap. In this video, we covered the so-called logical operators in MATLAB. There is and, or, and not. And for the and, it's represented either by the single ampersand or the double ampersand. This is a simple truth table that we are showing here for the AND operator. This double ampersand only works with the scalars. It uses a short circuit theme. Single ampersand works with the scalars and arrays, but there is no short circuit here. Obviously, you want to do short circuits if you are dealing with the scalars and you have a lot of computations, logical computations. The OR operator is represented either by the double or the single OR. Similar to the AND, the double OR works only with the scalars and uses a short circuit. Single OR works with scalars and arrays, but it doesn't use a short circuit. Finally, the NOT operator just flips. If something is true, it becomes false. If something is false, it becomes true. And one thing that's very specific to MATLAB, that any non-zero number is automatically considered true by MATLAB. All right, thank you so much. See you in another video.